The topic is the interior of the Earth. Earth is the fifth largest planet of solar system. Earth is a sphere. Length of the equator is maximum. It is known as great circle. The temperature from the surface of the Earth to the interior to the core of the Earth is gradually increasing. Rather, there is a positive relationship of the temperature and the depth of the Earth. When we start journey from the surface towards the core, towards the interior of the Earth, the temperature is gradually in increasing trend. On an average, the interior temperature of the Earth is near about 5000 degrees centigrade to 7000 degrees centigrade. It is almost very similar in the interior temperature of the Sun and the interior of the temperature of the core or core of the Earth. So, Earth interior is in the molten condition. We are very familiar that two things, landmass that is solid state and the ocean surface that is liquid state. And in between solid and liquid, there are wetland, there are certain viscous state. Same analogy, same principle is applied for the interior of the earth. Interior of the earth segmented into the three halves: solid state, that is the surface, and the liquid state, that is due to intense pressure and the temperature. The interior of the earth is in liquid state. Okay, core is in liquid state. In between solid and liquid, the intermediate part is in the viscous state. With the help of seismic wave, rather earthquake wave, we can get idea about the interior of the earth. With the help of seismographs, that is the graphic recordings instrument of earthquake waves, we can identify the different layers of the earth interior. Normally the seismic waves recorded through the Richter scale, it is nothing but the instrument to identify or to record the magnitudes of quakes, and that seismic wave scale, that is Richter scale, is a logarithmic scale. Basically, there are two types of seismic wave. First one is the body wave and second one is the surface wave. Now question is, what is body waves? Body waves are those waves which can travel through the interior of the earth. Rather, body waves is related to the body of the earth, that is the interior of the earth. And there are two types of body waves. First one is the primary wave. This is also known as longitudinal waves, and it is also known as compressional waves. And second one is the shear wave or S wave or transfer waves. Uh, P waves and secondary waves, that is S wave, those are the example of body waves. And body waves, basically P waves and S waves, is related to the interior of the earth. We can get idea about the body of the earth, that is the interior of the earth, through the S wave and P wave. Those are the body waves. And now come to the point of surface wave. What is surface wave? Surface waves can only travel to the interface. What is interface? Like between the earth's surface and atmosphere. Rather, it moves through the surface, that is the lithosphere, that is the uppermost part, that is the surface. Surface wave travel on the interface, like between the earth's surface and the atmosphere. Surface wave have larger amplitude and longer wavelength than the body wave. Surface wave is more destructive. It is also known as, there are two types of surface wave, known as L wave and R wave. Rather, earthquake waves, which are more destructive, are the surface wave. We can get idea about the surface of the earth through the surface wave. Those are the L wave and R wave. And we can get the idea or information about the body of the earth, that is the interior of the earth, through the body waves, that is P wave and S wave. To know the interior of the earth, we can take the help of three types of seismic waves. Those are P wave, S wave and L wave. P wave is known as primary waves, also known as primary waves, S wave for secondary waves, L for the lab waves. P wave is known as primary wave. It's just like a sound wave. It can passes very easily through the solid and liquid medium, but not through the viscous medium. It is also known as longitudinal waves. It's a compression waves, and it is mainly confined in the topmost layer of the earth, that is the solid state, that is the lithosphere. Let's have a look the P waves. P waves is also known as compression waves and longitudinal waves. Why it is called longitudinal waves or the compression waves? Because let's have a look to the direction of the propagation. This is the direction of the propagation. Longitudinal waves or the P waves vibrates through the medium. Medium vibrates parallel to the direction of the waves. Here, the direction of this is the direction of propagation, and the medium, those are the medium. Black straight lines are the medium. A medium propagates to the direction of the wave, direction of the wave's travels. That's why it is called as a longitudinal waves and the compressional waves. Suppose the black points are the medium. Here the medium is moving towards this direction, and the waves is moving. That red line showing the direction of moving. Direction are moving towards this, towards right hand side. Here both the medium is moving in right hand side and the wave's propagation, the wave is moving to the right hand side. Both are parallel. In the cases of P waves, the direction of propagation and the direction of the movement of the medium are almost parallel. This is known as longitudinal waves as well as the P waves. This picture also shows that the longitudinal waves propagates in that direction, and the medium that is also moving in the direction of propagation. Okay, and that's why it is called as a longitudinal waves, and that is P waves can passes through the fluid and the solid, not the viscous medium. S wave is known as secondary wave. It is just like a light wave. It cannot passes through the liquid medium. That's why S wave absent in the core, because Earth core is in liquid state. It is also known as transfer wave. It is just like the water ripple. S wave is also known as shear wave and as well as transverse waves, because here the waves move side to side and ups and downs, rather backs and forth. Its travel to the direction perpendicular the direction of propagation. Propagation means the direction of waves, that waves is moving. This is the direction of propagation. The waves moving towards this direction. Okay, and here the particles or medium are moving or oscillating in the perpendicular, that is 90-degree angle, perpendicular to the direction of the moving or the direction of propagation. That's why it is called as transverse. Transverse means it almost perpendicular to the direction of movings towards that direction. It is also known as shear wave. S wave is slower than the P waves. It cannot pass through the liquid. Here it's a propagation direction. Here the shear wave or ES wave moving or following the transfer direction to the propagation direction. This is the S wave, and S wave cannot passes through the liquid. This is the propagation direction, and this is the ups and downs of S wave. S wave don't travel at first as P waves. Rather, S wave is slower than the P waves. First one is the P wave. This is the propagation direction, and the particles also moving in the direction of propagation, both are parallel. Next one is the S wave. This is the propagation direction, and the particles are moving ups and downs, that is following the transverse direction of the propagation direction, that is known as transverse wave. And last one is the surface wave. Surface wave is more destructive than the P wave and S wave, but S wave is slower than the P waves. First one is the P wave. This is the propagation direction, and this is the motion direction. Both are parallel. That is known as longitudinal wave. This is the S wave. This is the propagation direction, and this is the motion of the particles, that is perpendicular to each other, that is known as transverse wave. And last one is known as surface wave. Surface wave is quite different from the P wave and S wave. Surface wave only occurs when it can occurs along any boundary of two different substances like earth surface and atmosphere. Okay, we are very familiar with the surface wave. Earthquake waves is normally known as surface wave. Surface waves are two types, known as first one is the love wave and next one is the Rayleigh's wave. Both are the two types of surface wave. Surface wave is basically related to the earthquake. P wave and S wave helps to get idea about the interior of the earth. Let's have a look of love wave. This is the direction of propagation, and love wave have a back and forth motion. That is back and forth motion. Okay, like a rattlesnake traveling over a snake. If you observe minutely, this is just like a rattlesnake moving over a sand. There is a back and forth motion. This is L wave. It is very devastating and related to the earthquake waves. It's a R wave. R wave is also the earthquake waves. It's related to the earth's surface, not the interior of the earth. R waves have an ups and down rolling motion. Here ups and downs rolling motion. Okay, and many people describe the R wave as a riding on a sea on an ocean. Okay, surface roll on wave. It is also known as surface roll on waves. Okay. Let's have a look how the surface wave is so devastating. Here it's related to the outer surface of the earth, and it is normally known as earthquake waves. Okay, this is the direction of propagation. The surface waves are very similar to the ocean waves. It is only observed in the surface of the earth, and it is totally absent in the interior of the earth. There are two types of surface wave, L wave and the R wave. This is the systematic presentation of P waves. This is longitudinal waves moves parallel to the direction of propagation. This is the S wave, moves perpendicular to the direction of propagation. Okay, that is R wave. It is just like a rolling or moving ups and downs, and this is the love wave, just like a rattlesnake motion. On the basis of the speed of seismic wave, particularly P wave and S wave, Earth interior is segmented into the three parts. The outermost part is known as lithosphere or crust. This is solid state, and the innermost part is known as core, that is in liquid state due to high pressure and intense pressure and high temperature. And in between solid and liquid state, intermediate part is known as mantle. This is viscous state. So earth is segmented into the three parts. Solid part is known as crust, that is the topmost layer or the surface. It is known as lithosphere, and the innermost part or core is known as core, that is in liquid state due to pressure and heat. And in between two state, in between two crust and core, that is mantle, that is in viscous state. The topmost layer of the Earth's surface is in solid state. It is known as lithosphere, and the innermost part of the Earth interior is in liquid state due to high temperature and intense pressure. This is known as core. And in between the solid and liquid state, the intermediate part is viscous state, that is known as mantle. The in between the solid state, first one is the solid state. Lithosphere is the solid state. In between solid state and viscous state, that is in between the zone of lithosphere and mantle, there is a discontinuity zone, because the S wave and P wave suddenly changes their speed, that is known as Moho discontinuity. And in between the viscous and liquid state, due to changing the speed of seismic wave, this in between the boundary between core and mantle, it is known as Gutenberg discontinuity. So earth interior is segmented into the three parts. First one is known as lithosphere. Lithosphere is a extension of lithosphere is up to from the earth surface to up to 27 kilometer. Then mantle, and then interior of the earth. Mantle from 727 kilometers to 2900 kilometers, and core is 2900 kilometer to 3600 kilometer. So it is the internal structure of the earth. Lithosphere is segmented into two parts, CL and SEMA. Mantle is segmented into the two part, upper mantle and asthenosphere, and core is segmented into the two part, outer core and inner core. The topmost part, that is solid part, is known as lithosphere, or the surface of the earth or crust of the earth. Crust is divided into the two part. Topmost part of crust is known as Sial, and the bottom part is known as Sima. Sial is the Sial is the abbreviation of silica and aluminium. Those are the basic composition of the topmost part of lithosphere. It extended up to the depth of 0 to 30 km. The average temperature of the lithosphere of that part is 500 degrees centigrade. It is comparatively less dense, and POF passes through the Cl. And next part is Sima. Shima is the combination of silica and magnesium. It extends from the 30 kilometers to 200 kilometers. The density is 3.3, and average temperature is 1000 degrees centigrade. It comparatively denser than the Cl, and POF passes through it. Through the chart here, I describe the lithosphere. It's a combination of Cl and Sima. The depth and the temperature of Cl is 500 degrees centigrade, and Sima is 1000 degrees centigrade. It is extend up to 30 km from the surface. It is 30 to 200 km from the surface. The density of the topmost layer, that is Cl, is 2.9 gram per cubic centimeter. At Sima is 4.3 gram per cubic centimeter. Cl is the combination of basically the granite and silica and magnesium. It is a important combination. It is the basic basaltic in nature, and through the Cl and Sima, P and S wave can travel, but the speed is not uniformly distributed through the Cl and the Sima. Next part is known as Asthenosphere. Asthenosphere is in viscous state, and S wave and P wave passes through it. The topmost layer of asthenosphere, known as mantle. Mantle extended up to 200 km to 700 km. Average temperature of mantle is, topmost layer of the asthenosphere is 1100 degrees centigrade. And next, lower part of the asthenosphere known as asthenosphere, it extends from the 700 kilometer to 2900 kilometer. Average temperature is 3700 degrees centigrade. Asthenosphere is known as low velocity zone because of it is extremely high in density. Density is maximum in asthenosphere, and velocity of the seismic wave is minimum here. That's why the suddenly P waves and S wave disappears in that zone, and this is known as low velocity zone. Asthenosphere is very dense. Okay, and lithosphere, that is the topmost layer, is floating over the asthenosphere, and asthenosphere is in viscous or in molten conditions. And innermost part of the earth interior is known as core. Core is segmented into the two parts, inner core and outer core. Inner core is the temperature of inner core is very high. This is 5100 degrees centigrade, and outer core is 3700 degrees centigrade. And inner core basically it's very hot and molten condition. Core is in liquid state. Nickel, ferrous are in molten condition, and it is very hot and very liquid state. The topmost layer is known as lithosphere. It is segmented into two parts, that is seals, and lower part is known as sima. And in between seal and sima there is a discontinuity. This is known as corner discontinuity. On the basis of the speed of seismic wave, this discontinuity zone has been identified. And next one is the mantle. Top of uppermost part of the mantle is known as mantle, and lower part of mantle is known as asthenosphere. In between lithosphere and mantle there is a zone of discontinuity. This is known as moho discontinuity. And the third part, that is in liquid state, that is core. Core is segmented into the two parts, inner core and outer core, and the boundary between the mantle and core is known as Gutenberg discontinuity. Okay, and on the basis of inner core and outer core there is a boundary that is known as Lehman discontinuity. Okay, so therefore on lithosphere, in between lithosphere and mantle there is Moho discontinuity. In between mantle and core there is a Gutenberg discontinuity. And within the lithosphere, the boundary between the Shial and Sima known as corner discontinuity. Within the core, the boundary between the outer core and inner core is known as Lehman discontinuity. Okay. Here a list has been prepared to identify the thickness of the crust, mantle and core, and the density and the types of the rock. Okay, main rocks types of the crust are the silicic rocks, basically granite and basalt. The rocks in the mantle are basically magnesium, silicon oxide related to magnesium and silicon oxides, and peridotite, olivine, so on. And the rocks and the minerals type in the core, basically it is called an Nifeshima, that is known as nickel alloy, and iron, that is ferrous and related to nickel. Earth internal condition is related to or the responsible for the formation of Earth magnetic field, and the core, that is this is the core zone, it's occupied 22% areas of Earth interior, is a zone of conduction. And the mantle, that is the mantle, lower mantle known as the sphere, this is upper mantle, it is a zone of convection or convection current. Okay, this is the zone of convection. Okay, and upper part is crust is a zone of advection.